Solar heated air can heat a house. Let's build a hot air collector and see how it works.
Hi, John Canavan. Well, it's approaching the end of the heating season and we don't really need solar hot air collectors so much, but you might want to get ready for next year. Anyway, there's been a lot of discussion on the internet, especially by Gary Reese and Scott Davis about solar hot air collectors, and they've come up with some very unique designs, and I thought that I'd throw my 2 cents in another method of building a solar hot air collectors. Some people use pop cans. They've also used aluminum soffits, aluminum screens, and also nylon screens. There's a number of ways that you can change light into heat and then bring it into your living quarters. Anyway, rather than using metal heat transfer plates as the absorber, I thought I'd give it a try and use polyester felt. This is the kind of thing that I use quite a bit in my MTD collectors. So I had this idea of, in the same way that you use a screen to blow air across the screen to pick up heat, I thought I'd use this polyester felt. Okay, so the first thing that we're going to have to do is build a frame for our collector. Now I like to use steel stud slots, and I think this is what Gary and Scott also use quite a bit. And it's pretty easy to work with. All you have to do is you just bend your steel stud slot. This is 3.5-inch steel stud slot. And then you connect it to a runner like this. From here you can pop rivet the flange and make your frame. So we're going to go into the details of that. That's simple enough. You can do that. But once you have your once your frame is constructed, the next thing you're going to do is you're going to need some insulation. Now the nice thing about this type of collector is that we can use the insulation for the backing. You don't necessarily have to put plywood in the back. You just slide this, you cut a sheet of insulation. Now since we're going to be using the Sun Tough glazing, it measures 25 inches across, so the insulation will be 25 inches. Actually, it's 26 inches, but when you cut the flange, it's 25. Anyway, okay. Anyway, so for the bottom of our collector, we'll use this isocyanurate insulation. You can see I have 2 pieces of 1/2-inch insulation, but you'd probably use 1-inch insulation. Okay, so that's the bottom section. Now we can hold that in place with another piece of insulation. Just press that into the flange like drilled, that. And this is the bottom baffle system, and the top we just have a straight. Attach our polyester felt. We're going to be using the polyester felt instead of a metallic absorber plate. So it's sort of like the idea of the screen. So we're going to be blowing air right through this. So I've already secured this to wooden strips on either side. You can see I just stapled it. No big deal. So notice the way I'm putting it in. I'm angling it so that the angle it goes in towards the top and it's out at the bottom. So the idea is that we're going to be pumping air from the bottom of the collector, and it'll hit this, first it'll hit the bottom of this 2x4, and then the air will be channeled out and under the polyester felt. But since the pressure of the air is going to be greater on the bottom of the felt than on the top, the air will be forced to blow right through the felt. Okay? At least that's the idea. Huh. I don't know whether it'll work or not. No, I tried it. It does work. How well it works, I don't know. That's something else again. So once the polyester felt is in place, and I get the camera lined up, you can see that it's loose on this side. So when you staple it, you want to staple it so that it will be tight when it's fastened to the side of the collector. Okay? I don't know if that makes sense, but so all we'll be using to hold this in place is there's 2 screws on the top here. Remember before I put these screws in under this flap. You can see 1 screw over here, and there's another one on this side. And then there's going to be 2 sides going through the side of the collector. Okay, I'll put this over here. So we have 1 screw on this side. And all these screws do is hold the frame for the polyester. Okay, if you use sun-tough glazing, you're going to have to find some way of sealing off the indentations on the glazing. So you could use wiggle strips. That's probably the best thing to do. These side supports are actually made from steel stud slots. If you take a steel stud slot and rip it in half, you'll have these angle irons. Or you can buy angle irons ready-made. Okay, thanks for your patience in watching this demonstration on the assembly of a hot air collector that uses polyester felt. Remember, you can also use aluminum soffits, aluminum flashing, or you could use aluminum screen, or you could even use a nylon screen as an absorber plate. There's many ways you can build a hot air collector, and this is used for home heating, but you're going to need more than just one hot air collector to heat your house, believe me. But this is another alternative to solar heating, and this is the kind of thing you could do yourself. And once you get into it, I'm sure you're going to come up with some wonderful designs of your very own. So get started today!
We should be able to estimate the efficiency of a hot air collector if we know the sunlight intensity, the surface area of the glazing, the flow rate of the fan, the weight of a cubic foot of air, the heat capacity of air, and the difference in temperature between the air entering and leaving the collector. Notice the temperature at the top of the heat storage chamber reaches 135 degrees Fahrenheit around 3:30 p.m. As soon as the fan comes on, the temperature of air from the collector drops and the temperature of the air returning to the collector rises. By 4 p.m., the temperature differential stabilizes at 22 degrees Fahrenheit. We'll use this temperature differential to estimate the heat harvest of the collector. Air weighs 0.075 pounds per cubic foot and has a heat capacity of 0.24 BTUs per degree Fahrenheit. If the flow rate of the fan is 20 CFM and the differential in and out temperatures of the collector is 22 degrees Fahrenheit, what is the heat gain per hour? How will this heat gain change with sunlight intensity and time of day?